Hello. Looks like
live stream going, so that will be up. And you'll also get the recording of this in your inbox tomorrow at the same time. And we'll have a link to all of the resources from the presentation. So thank you guys for joining us for the second staff-hosted webinar in our series. So that will be up. I hear myself streaming. We have Felix here, our senior support engineer, to walk us through ProCalc and unlocking the full power of Nexus. So the Q&A is open. I'll be monitoring that. You can send in your questions and we'll answer those at the end. You can chat to us. And with that said, I'll go ahead and hand it over to Felix.
Hey guys, welcome to the ProCalc webinar, Unlocking the Full Power of Nexus. I want to thank you guys obviously for the opportunity to speak to you guys. I've been with Vicon for 8 years now, and I think this is my first webinar, so go easy on me. As Alicia said, we will be doing Q&A at the end. I'd hoped to kind of do it during so that people could ask questions as we go, but I don't think I can actually monitor the questions at the same time as sharing my screen, unfortunately. So this is the second part of the webinar series. As I said, it's going to be 5 parts. So every Wednesday, just note the time change for next week. And again, I'll go over that at the end, just so you guys make sure that you don't miss out on that, because there's some pretty interesting topics along the way. But for ours, it's going to be about ProCalc. So it's going to be 3 parts. Actually, let me just share as an actual presentation instead of doing it one slide at a time. So in our introduction, we're going to talk about the motion capture workflow. We're going to talk about what is ProCalc, and then talk about some use cases, because some people don't really know. I mean, they're aware of ProCalc, but not sure how it might actually fit into their workflow, or what people are using it for out there. Then we'll go into the basics, and as much as possible, what I'm going to do is I'm going to make sure that I'm actually operating within ProCalc. So there are a lot of slides within this presentation, but I'm going to try to not use them as much as possible. And what'll happen later is I'll make those slides available so that you can use them as a reference, so that you can try some of these examples out on your own. So we'll go over the basics within ProCalc, the requirements for using ProCalc, the layout, and how to actually navigate within the software. Lastly, we're going to get into the examples, probably the most interesting part. So we'll look at a simple angle, we'll do a 3D joint angle, we'll look at a virtual marker creation, and then lastly, we'll look at how we can use ProCalc to actually generate a VSK, and maybe why we might actually do that. So what is the motion capture workflow? Last week, you guys heard a really good presentation from Derek and Mark about unleashing more flexibility, more power, potentially better quality data from your Vantage cameras. And that kind of fits in right at the beginning, right? So that's what's going to be the avenue for which you actually obtain your data. Then once you get that data, it's up to you to decide, okay, well, you have all these marker trajectories. How are you going to actually get any analysis out of it? And that's going to be more so on the output side. So you're going to get all these marker trajectories. It's up to you to figure out, okay, how am I going to get, let's say, a joint angle out of that? And how am I going to get some parameters? How am I going to figure out what some key events are going to be during my trial, like peak knee flexion or something like that? And that's going to kind of fit in over here. So we looked at, improving your data quality. Now we're going to look at, okay, now that we've got this great data quality, what are we going to do with it? Or what can we do with it? And of course, there are other options, but I'm here to kind of tell you why it's advantageous to potentially use ProCalc. So what is ProCalc? Well, it's a wizard-based modeling companion to Nexus. And what we mean by that is you don't need to learn a scripting language in order to use it. What'll happen is if you want to, let's say, get a certain output or anything like that, it will prompt you with different inputs that you can use. So let's say you're looking for the midpoint between 2 markers. It'll say, okay, well, we need 2 points. You just need to click on the screen what it is. It doesn't say, okay, well, you gotta read this manual, learn all the scripts, and then do it. It'll prompt you to choose the right inputs. What you can do is you can create and apply kinematic models. You can identify key events within your model or within your trial based off a very complex logic logical events potentially. And then you can also create key parameters, as I said. So you could look at what peak knee flexion might be during your trial, or look for certain averages of your knee angle potentially throughout the trial. And the important thing is a lot of these resources can actually be found at the website located down below. The easiest thing to remember really is the docs.vicon.com down here at the bottom, and then you can navigate to where you might find that ProCalc documentation. So some use cases, I've got 3 up here. So the first one is, let's say you want to do some animal studies. You put some markers on there. We obviously don't have or our models readily available for doing rat studies. So you put on some markers, you get your marker trajectories in Nexus, you label them, you track them throughout the entire trial, and then it's like, okay, well, what do you do next? A great option would be to take them into ProCalc, create some vectors, get some angles, and then create your report so you can figure out, okay, well, what are the angles at foot strike and foot off, et cetera. And that's a great way to create your kinematic model and then get the outputs that you need. Down below on the bottom left, you're doing a bike fitting, for example, and there's certain parameters that, let's say, a plug and gate or any other model out there doesn't provide for you. You can go ahead and create your own parameters and start monitoring things like the left knee to shoulder angle or something like that. Lastly, on the bottom right, we have an example of where you might want to generate a VSK. So the VSK, for those that aren't really aware, is the calibrated version of your template. So when you go through and you calibrate your subject, you're hoping that the template can actually help to label your trial accurately or efficiently. Sometimes that's not possible, despite your best efforts to get a very good range of motion trial or to optimize your template beforehand. Sometimes this isn't possible. And you just know that, hey, I know that there's joints here. I know how they're roughly going to move. I'd prefer them to be in this way. Alternatively, if you do have a trial where you've got this kinematic model that you've been processing offline and you say, well, actually, I'd like to be able to see if I can visualize some of that in real time. This would be a good way of making sure that your kinematic model actually matches your labeling skeleton model, thus being able to get those outputs in real time. So I think what most people think is that ProCalc is kind of a research tool, is kind of used mainly to develop these models, et cetera. But what hopefully you can kind of get out of this as well is that it's a great teaching tool as well. So it's, you know, a great opportunity to show students or potentially people that are just new to modeling or new to biomechanics and just say, hey, this is how we can go ahead and create some vectors. This is how we can create segments using the right-hand rule. This is how Euler angles kind of work. And because it is wizard-based, as you'll see, we'll be able to kind of switch the direction of our vectors, our definition of our segments, et cetera, very easily. So hopefully you can see the value in it being a teaching tool as well. So what are some of the basics? We'll just go over what some of the ProCalc requirements are. The first one is that you do need a valid Nexus 2 license on that machine. And then you're going to need ProCalc 1 installed right now. We're on ProCalc 1.4. You will need labeled C3Ds. You don't necessarily need a good template or anything like that, but the markers do need to be labeled within your C3D. It would be helpful, obviously, if you did have some basic biomechanical modeling principles, because we will be doing things like creating segments, calculating Euler angles, and that kind of thing. And the last one really is definitely optional. It's just if you have Office or more specifically Excel installed, because what can happen is if you want to export some of these parameters, especially at certain events, it will export by default to Excel. That doesn't mean that you can't get that data elsewhere. It can be exported as a CSV or something like that, so you could parse the data through like a notepad or something like that as well. So this is the ProCalc layout. As I said, I'm going to try to, as much as possible, work within ProCalc so that we can see that and not just look at slides the whole time. So let's switch over to ProCalc right here. So we'll see the same windows. I've just kind of hidden some of the directory tree over here, but you should recognize at least the top left side of the screen right now. That's going to be your data management. This is very similar to the data management that you see within Nexus. So that should be fairly familiar. But this whole left side in general is referred to as your controls, because it allows you to choose which schemes you want to be working in, what trial you want to be working in, and then how to actually process your data later. Over on the right-hand side, you're going to have your 3D workspace, and this will generate, or this will be controlled similar to Nexus. So you'll actually be able to see your markers in real time, as well as the labels. Down on the bottom right, you have your output. So anything that you calculate within your schemes, it'll show you what those values are, and it'll do it by frame. So you actually have your time bar here as well. As I was talking about, we do have schemes that go across the top here. That's how we control, or we put inputs or calculations or define our kinematic model in Nexus, or sorry, in ProCalc. And the important thing really is that you have to have a trial loaded before we go. So if you see, if I try to click on input parameters right here, if I click on it, it'll say, please load some data before changing the tab. So I'm going to go ahead and do that. What I did was I captured a lot of data. So we're not going to spend any time today in this webinar collecting any data. We're just going to be looking at it in ProCalc. So here you can see I've got 3 simple markers. I've got a marker that's on the shoulder, the elbow, and the wrist. And we're going to go through making a scheme together. Even though I've already created one, we'll just go through and work through this together. Okay, so the first thing that I could do is I could add in an input parameter. So if I wanted to create a new scheme, I would click on this plus button. I would just type in a name, for example, and then each scheme is defined by elements. So an element could, in input parameters, be any constant. So it could be the value of pi, right? And I just type in 3.14 and add. Then I could go ahead and save that scheme. Okay, a variable is going to be any time series data that is between events, and that could be between foot strike events. It could be the first frame, it could be the last frame, or anything like that. So it's anything that is time series data between events. An example obviously being like a knee angle or something like that. The third tab over here is going to be your events, and as I said, you can identify key points within your trial using very complex situations. So if you want to look at, what peak knee flexion is after foot contact or something like that, we can certainly do that. So you can generate pretty complex events. The last thing is going to be parameters, and this will be any discrete variable data. So when you're looking at a certain moment in time, whether it's peak knee flexion or something like that, you want to know a value, or you want to know the average over over a time period. So it's going to be one data point or a series of data points just for that one moment in time. So we already talked about navigating and adding in an element. So we're going to see more of that in a second, because I'm going to go through an example really quickly here. So let's look at this one right here. This one's actually going to be a simple angle. So we will go into our variables tab, and we'll go ahead and create a new scheme. So we will call this simple angle. Okay. I'm going to go ahead and add an element over here on the left-hand side, and I will give it a name. I'll just call it elbow angle. Okay. Each of my elements is defined by a function category and then the function itself. So the category here is actually going to be an angle, as I said. And if I look here in my list of available options, it gives me either an angle between A and B, some Euler angles, or some continuous Euler angles. As I only have 3 points here, I can't really create any segments, so I won't really be able to make an Euler angle. So it's really just going to be an angle between A and B. Okay. As soon as I choose that option, you can see that I've got 2 inputs, and they want them both to be vectors. I don't have any vectors right now, so I need to go ahead and create those vectors. So let's go ahead and do that. So I'm going to add in another element. I'm going to call it the upper arm. And under my function category, I'm going to choose vector. And then I'm going to select from point A to B. So sometimes you're obviously very restricted by the markers that you choose. So having some knowledge of what you're trying to do in ProCalc, or some of the calculations that you're trying to make in ProCalc, will govern where you'll probably want to place your markers. So it's kind of a little bit of a chicken and egg situation, right? Because you want to get these outputs, but you're not exactly sure how to do that. So it may take you some iterating to figure out what is the best way to get the markers on there to get the outputs that you need. Okay, so you've got your vector and then your 2 points. I will choose my shoulder, and then my elbow as my first vector. So as soon as I do that, you can see that I've got a preview of that vector. I get that in the output log as well. I get the vector direction. Okay, and then I'm going to do the same thing for the lower arm. Again, the category is going to be a vector. I'm going to choose from point A to B. I'm going to choose now my elbow to my wrist. Again, getting that preview there. Okay, now I can go back up to my elbow angle. Now that I have two vectors, I'm going to choose that A to B again. It's going to ask for those two vectors. I'm going to specify the upper arm and then the lower arm, and then you get a preview of that angle. Now you look at that angle and you think, is that actually the angle that I'm interested in? Is that the angle that I want? Potentially not, right? So you have many options here. Maybe you actually want this complementary angle here. What I can do is I can multiply that upper arm and kind of change its direction, right? So now you're actually getting the angle that you want, but perhaps this isn't really the display or where you want that angle to reside. So we have other options for changing that as well, right? Even though the angle itself is calculated as what you want, it just doesn't look quite right. So what we can do is we can go back into the upper arm. So if you kind of realize that it's going to put the tail of the second vector onto the tail of the first vector, right? So I've got my elbow angle here. The upper arm vector that begins at the shoulder, and it's going to translate this vector back to that shoulder point. Knowing that, I can just change the direction. I can swap the 2 points here. I can change this to elbow and to shoulder. Right, so now my vector has changed direction. Now when I go back to my elbow angle, you can see that that's probably the angle, at least as it's the same as before, but it's actually the angle that I want to appear when I'm creating my model. And it just makes it easier to kind of interpret what is going on. And then I can go ahead and just kind of play my trial, and you can see that angle changing, and you can see the outputs as well changing within the log. Okay. So what I can do now is I can actually save this this variable to a C3D so I can load it back within my trial, right? Because that's most likely what you're going to want to do. You're going to want to visualize it actually in Nexus, and then maybe do some other things with it, bring it into Polygon, etc. So I'm going to go ahead and save that scheme so that I can use it on multiple trials. I'm going to go back into data management. And in order to process that trial, I'm just going to right click on it and select mark. Okay, I'm going to make sure that I've got my schemes identified here. So I'm going to choose the default here. And the only thing I've really done is created a variable scheme, right? That's called simple angle. I'll go ahead and select processed mark trials. And what I can do is I can go back into Nexus now. I'm going to open up that trial. So right now, you can see here I don't have any model outputs. As soon as I reload this trial, you should see I have a model output here. It's going to be an angle, and it's elbow angle. And I show the graph, and it's going to be the same output that you saw in ProCalc. Okay. Alternatively, what we can do is I've got the same trial doing kind of the same thing, just some elbow flexion extension. I'll play that trial just for you guys to see. This one, again, has no model outputs, but I can actually process these schemes within Nexus as well. So let's go ahead and create a new pipeline. We'll see that under data processing, I have an option to run a ProCalc operation. I'll go ahead and specify my scheme again, which is going to be the simple angle. I don't have anything else, and I'm going to go ahead and process it. So as soon as I've done that, you can see now an angle popped up on the left-hand side, elbow angle, and you get the display as well. So there is one fundamental difference between doing this within Nexus versus ProCalc. If I do this within ProCalc, it automatically saves the C3D. That's not necessarily a problem, but it's just something to note. When I do this within Nexus, it doesn't save the C3D, right? I can still see the asterisk here letting me know that the trial is actually dirty and requires me to save it, okay? It's not a problem because if you, let's say, made the wrong calculation within ProCalc and you wanted to delete it, you can just right click and just say delete model output, and you can start over and redo your ProCalc scheme again. But in this way, you can mark as many trials as you want, or you can do a batch processing by saving a pipeline and process as many trials as you want as well. So it's quick, it's powerful, and you can write it back to the trial very easily, which is probably an advantage over some other means of modeling, perhaps. So I'm going to just go ahead and save this trial, and we're going to move on. We're going to move on to a more complex model. But just to kind of take you back to the presentation just for a second, that is here. So I talked about the layout, talked about the schemes, I talked about navigating within a scheme, and then we started going through the simple angle example. So I just wanted to show you that you do have some notes here that will help you, and I will make these trials and these schemes available so you can try them out as well. Okay. So just letting you know that there are definitely some notes here for processing both in ProCalc and in Nexus. So I'm just kind of skip through this kind of quickly. So the next thing that we're going to do is we're going to look at a 3D angle, right? Probably more useful for us. Most of us probably use Nexus more for 3D angles rather than 2D angles. So let's go back into ProCalc and we're going to unmark this trial and we're going to go into our 3D angle session. So now you can see I've got significantly more markers. I've got 6 on there for the upper arm and the lower arm. Again, I'm just doing some simple flexion extension. Okay. In my variables tab, I've actually already created the scheme because I don't want to spend too much time looking at creating the elements, but just giving you an idea of what you can do so you can see the value and the power of ProCalc and how it can improve upon your motion capture experience. So let's look at the 3D angle. More elements in this one, right? So what are some of the first things that I did? I created midpoints for the shoulder. Again, you're getting the preview on the right-hand side so you can see that. I created a shoulder, an elbow, and a wrist. I used that to then create some vectors for the upper arm, an anterior posterior, and then a medial lateral, and the same thing for the lower arm. I then used those to create segments. So I'll just unlock this just so you can kind of see what I've got here. So I've got my segments here that were defined using the midpoint and then 2 vectors. I could have also made my segments based off of just 3 points. The only problem with this is that it doesn't offer as much flexibility. As you can see that my points or my vectors need to originate at the same point as the origin, which doesn't necessarily give you the vectors that you would want to cross necessarily. And this is where having some of that those biomechanical principles would help because it would help you choose the correct vectors that you wanted to use. So you can see here very easily I can change the orientation of my segments very easily. So here I've chosen that my origin is going to be A at the mid elbow, and that my first axis, the long axis, is going to be my Z, which is the upper arm anterior posterior vector, and then it's going to be crossed with the medial lateral to actually give me the flexion extension, the axis. So what I could do here is I can change these, and you can see those segments changing very quickly, right? So it allows you to choose the right vector or segment orientation very easily. So I'm going to go ahead and cancel that and not save it just so that we can get the angle that we want. And then ultimately what I get is the elbow angle in 3D like I want. Same thing, I can go ahead and let's just make sure that I've actually output that to the C3D. So let's choose elbow angle, and you can see that this has been checked. So when I go ahead and process this now, so let's go ahead and mark it again, and we'll process the mark trial. We'll go back into Nexus, and let's look in the 3D angle. And now I've got the elbow angle there as well. Okay, I'm going to take this example one step further. I've also created an event. So let's go ahead and look at that. Webinar 3D angle is my scheme there. And all I wanted to know is I want to know when the elbow angle attains a maximum value. Okay. As soon as I click on that definition, you can see I've got these little carets in my time bar. That's letting me know when exactly I'm getting those peak elbow flexions. Okay. Within my parameters then, I'm going to say, well, I actually want to know what those values are when it's at those points. So I'm going to select my 3D angle again. And maybe I should spend a little bit of time just looking at what I actually did to create that event. So let's go back for a second. If we edit this and highlight the general peak elbow, I looked at, okay, well, what is the Euler angle for the elbow at the maximum value when it is greater than 90 degrees? Only in the X, because that's going to be my flexion extension. If you looked at my my order of rotations, the x-axis was going to be the flexion extension. Okay, so I wanted to know exactly when this happened, and again, that happened when these carets are indicated within the time bar. Okay, my parameters, let's expose that just so you can see. Again, I just wanted to know what the maximum value was when that elbow angle was between two events, right? Between these two events and then those two events as well. Okay, I want to know when that would happen. Now when I go through, I've got these three schemes specified. I can go ahead and click Export Cycles. And then when I click Process Mark Trials, it's actually going to write a file to this folder that I've already specified. So if we click Process Mark Trials, let's go into that folder. And you can see it was just created. I'm going to go ahead and open it. And it can show me, well, what was the average and what was the standard deviation for the elbow flexion for that entire time. Then what was the peak elbow flexion for that first cycle and what it was for the second cycle. And you can create as many outputs as you want. What's nice too is, again, if I go back into Nexus, let's open up this trial again. Now I actually get these analysis outputs. So I get what was the peak elbow flexion for the first event, the second event, and then that third event as well. And then these can be exported as well as you need, or they're saved to the C3D, so you do have those outputs available to you. Okay, so moving along, let us just review. So yeah, we created some angles here, just looked at how different options for doing so, making those segments, and then creating those events, generating some parameters. And these values that are here are going to be slightly different because that one was processed on the second trial. But if you do the second trial, you should see that you will get similar numbers to what is actually shown within this slide. Okay, so next we're going to look at a virtual marker. Okay, so an example or a question is, why would I want to use a virtual marker? And maybe it's that you don't actually want markers on your joint line or anything like that, or you find that putting them on rigid cluster plates is a lot easier to track and that they don't fall off, etc. So this is a pretty typical use case, I would think, with a lot of customers. So we want to make sure that we can still get those joint markers, because ultimately that's how we're still going to define our joint centers, etc. So if we go back into ProCalc, let us go into our, let's unmark that trial first just so we don't accidentally process it later. We'll go, back into our virtual marker. So same thing here. Now this time I'm going to deal within the calibration trial first. So what I'm going to do is I'm going to create virtual markers out of the elbow markers. Okay. So you can see here I've got my elbow markers within my static trial. What I need to do is two things. I need to, let's go into a static. I need to create a cluster out of one of these two clusters or markers, or a segment out of these clusters or markers. So what I do is I've created a segment. I did have these examples for doing segments based off of vectors and points, but I can also just say, okay, I just want any orientation of cluster available. So I can just choose 4 markers randomly and it will automatically just choose a coordinate system for me. It doesn't really matter because it's all relative to this cluster. So as long as you have a coordinate system there, it shouldn't really matter what that is. You can go ahead and specify a specific one if you want, or make it more relevant to you if you want. The next thing I need to do is I need to go ahead and create a parameter. So this will be another use of a parameter. I want to actually save these 2 markers now relative to that local coordinate system that you just saw. So I've done that here. You can see here I've saved the left elbow, and it's giving you those local coordinates down here in the output relative to that upper arm cluster. So I'll need to go ahead and process that first. So let's mark that trial, and then we'll process it. And what it'll do is it actually save the parameters there into a different file type that's called the XMP file. So if you're looking within your session folder, you'll see a different file type, and that's going to be the XMP file. So let's unmark that, and now we'll go into our dynamic trial. So in our dynamic trial, you'll see obviously that those elbow markers are missing. So what do I need to do here? I need to create another scheme, And what I've done is I've actually used what's called a base scheme. So a base scheme will reference any other scheme that you've already created. And I've done so for that cluster because I don't want to have to recreate that cluster every single time. And you could have a much more extensive scheme here that you don't want to recreate every single element within it. So I've created, I've used that arm static base scheme. And then I've recreated that medial elbow and then that lateral elbow marker, right? And you can see that you get that preview as well. I can take this one step further and I can recreate those angles that you saw within that first example with the 3D angles. And again, you can kind of see how that would be output as well. One thing that I should note is, so obviously within each segment, I should have mentioned this during the 3D angles, is that, so if I look at, let's see, my upper arm segment, you have your axes here and then your lower arm segment here. The elbow angle axes will actually correspond to, so the XYZ, the blue, which is your X, your red, sorry, your red, which is your X, your green, which is your Y, and your blue, which is your Z, is actually going to correspond to the order of these of rotations here. So the Y-axis will actually be red because it's the first one in the list. The X will be your green axis, and the Z will still be your blue axis, despite the segment definition showing slightly different. I hope that makes sense to you guys. And again, I should have explained that earlier. I'm sorry. But yeah, so your colors here will correspond to the order of rotations here, as opposed to the segment orientations that you had earlier. Okay, so my last example here is going to be to generate a VSK. So let's go back to the presentation just for a second. So we've got our virtual markers. Just showing you an example. And then we're going to look at generating a VSK. So again, why would we want to do this? The first one is probably, as I said, you may not be able to, for whatever reason, generate a good template. You could do a great range of motion trial, but you're going to get an example that kind of looks like what we see here on the left-hand side, that the axes aren't exactly aligned the way that you want. The pelvis origin seems to be off, isn't what you would hope. And what you really want is something that looks like the picture on the right-hand side. So we're going to do the same thing. We're going to create segments in the same way that we did when we were calculating those joint angles. And the only difference is that they're going to be, their origins are going to be at the proximal end and not the distal end, as we had seen. So let's go back into ProCalc and look at how I actually defined that skeleton. So let's open up that trial. All right. And we do have an example that's loosely similar to this available on our docs page again. So if you ever want to try out any of these, please by all means, you might need to collect the data for that, but step by step, it'll show you exactly how to generate your own VSK. So here I do have some input parameters. A lot of them have to do with subject parameters. So what I did was I was able to reference the VSK directly. So for ankle width, I didn't even have to know what those were. I could just look in the list and look at the different measurements that were available to me, and it could calculate them for me. So if you do have parameters listed within Nexus, within your subject, you can go ahead and call those directly. You don't have to remember what they are. So I do have some here: leg length, ankle width. These are simple anthropometric measurements that a lot of people tend to use. So those are available to you. And then within my variables, and this is going to be much more involved than previous ones, I'm going to have quite a long scheme here. So again, this example is somewhat loosely similar to the one that's in the docs page. So you can kind of follow that along here if this is kind of overwhelming. What I first did was I created a pelvis segment based off of midpoints between the anterior and posterior ASI markers or NPSI markers. And that helped me form the orientation for the pelvis. I then used a regression equation to figure out what the joint centers were going to be for the hip. So there's my left hip joint center and my right hip joint center. The knee and ankle joint centers are just midpoints, similar to what I had done before. So here's an example of one and the example of another. And then I use the length, the length between the joint centers to create a femur segment for both sides. as well as the medial lateral vectors to create the orientation for each of these segments. So I've got my femur here, I've got my tibia here as well as my foot. So again, the one distinguishing thing that is different than the previous example where I had my arm is that all of these are actually have their origin at the proximal end and not the distal end. Okay, when I want to process this trial, so let's go back into Nexus really quickly so I can open this trial so you can see what the difference is or what actually happens. If I open up this ROM trial, and we'll split the screen here and we'll look at the subject viewer. And if a lot of people don't know what this is actually, well, at the beginning it's your VST, but as soon as you've calibrated, it actually shows you what your VSK looks like as well. We can see how this was calibrated just using a range of motion operation, right? It's still good, it'll label great in your trials, no issues there, but if for whatever reason, again, you wanna do something in real time, this may not get you exactly what you're looking for, okay? So this is what the VST or VSK, in this case the calibrated VST, looks like pre-ProCalc. And now if I come back in, I can just make sure that I have all of my schemes specified correctly. So under my event, let's set it to default, and as well as parameters because I don't have any. And really the only thing I had was the input parameters and the variables. Okay, I'm going to click on update VSK. It's going to give me a warning just to say, okay, this is what's going to happen. It's going to save the VSK, so make sure that everything is correct and make sure that segments, et cetera, match. And I guess that's something that I will talk about in a second when I go back into Nexus. So do I want to proceed? Yes. And then it's just saying, okay, you got to refresh your subject within Nexus. And I do have a video that's in our ProCalc YouTube page, our YouTube playlist that talks about this a bit more in depth as well. So please view that in the future. So I'll click OK. I'll come back into Nexus. We don't see anything change because, as I said, it prompted you to refresh your subject. So I'm going to right-click, refresh subject from VSK. And now we can see that it's changed the pelvis. The orientation of the femur and the tibia and the foot have also changed. If I need to see what it was pre, so let's go ahead and do that. This is what it was pre, and I'll expose the axes as well, just so you can see that. Right, so the axes orientations are a bit, different than what we would hope. If I reprocess that trial, you can see now that they have aligned to the directions that I would want, or the orientations that I would want. So this is a pretty valuable tool that not a lot of people are aware of, and it has a lot of different applications or reasons why you might want to do that. And then I can go ahead and save my trial as well. Okay, so what's next? I know that was a lot of different things. We kind of went through things quickly. As I said, I wanted to just kind of talk about the different options or what was available to you in ProCalc, and not necessarily make this into a step-by-step of how to do everything, but just, what are some simple things that you can do so it can get you thinking about how could I use this? How could this fit into my workflow? How could it fit into my pipeline? Well, hopefully this gave you some ideas. So what's next is practice. I mean, we're going to make these slides and these trials and the schemes available in a Dropbox link after this webinar is complete. But also just come up with your own questions. I mean, think about some questions that you may have and try to actually solve those questions using ProCalc. And if you need help, go ahead and contact us at support@vicon.com, and we'd be happy to help you. We like working in ProCalc as well because we see the value. There's a lot of things in there, so if you don't kind of practice those things yourself, I mean, you won't be able to kind of support customers. So I'm constantly kind of playing around in there and finding out new things myself. So definitely come up with some interesting scenarios and pass those along, and we'll be happy to help. As I mentioned, there is a YouTube playlist. I've created some videos there so you can see some of those examples in more depth. So should you want more in-depth how-to on each of these topics, please go to that playlist. And we do have tutorials that are written out in our documentation as well. Again, that's in docs.vicon.com under the ProCalc documentation. I do want to thank you guys for joining in. I know that we've got a lot of different time zones. I hope I didn't speak too fast for some of our international people, but I do welcome some questions at this time. And before I get to those, and I think Alicia is going to help me out in reading some of those questions, is that I just wanted to bring up the webinar series again. So you do have the one from last week, which you can review. So that was on Vantage Plus. And then you have in the following next 3 weeks, a Shogun platform update, a Vicon accuracy study, and then a great one from Dr. Tom Shannon on how research helps animators create more realistic characters. So without further ado, I do welcome some questions. And again, thank you guys for tuning in. So I think I need to stop my share, if that's correct, Alicia, in order to view the questions.
Yeah, I think so.
Oh, actually, no, it looks like, okay, I think I can still.
So we have one in there if you can view that Q&A
I do.
box. And then if you guys have any other questions, feel free to drop them in now and we'll start.
Because I do have some
working
things in the
through them.
chat, but let's see.
Yes, there's the one, is it possible to export in Excel the trajectory from ProCalc is the one in the chat here.
Okay. Okay, so I'm just gonna go through. So we got some hellos. The first question I answered, which was about the direction of the vectors. He asked, do we always have to go from proximal to distal, or could we do elbow to shoulder? I obviously changed that in real time so that you guys could see that. Okay, let's see. Okay, so another person just said thank you. They wanted to calculate joint angles between two segments, and this presentation answered that, so that's great. So then it says, okay, how is it possible to export in Excel the trajectory from ProCalc? So what you're going to do typically is you're not going to export the trajectories from ProCalc, but you'll do that from Nexus instead. So ProCalc will help you create some calculations, whereas a trajectory is not really a calculation. That's something that was already measured within Nexus. So I would do the exporting within Nexus instead of ProCalc. And then I just got okay, we're getting questions now, which is great. I'm just having a hard time keeping up with all of them that are coming in. Okay, so let's go back over here into the Q&A. Can ProCalc be used for looking at modifying existing models not created in ProCalc? Calculations done by plugging gate definitions, body language scripts. Yeah, definitely. So what I've done is, I think I've done in the past is, I've kind of done is create a ProCalc script that kind of matched plugin gate so that I could start looking at potentially getting plugin gate in real time. So, but also just for general understanding, right? Because I wanted to know what it would take to actually convert any bodybuilder scripts into ProCalc. So I went through that exercise with the goal in mind, again, of trying to get some real-time plugin gate. So definitely I would say that ProCalc can be used to look at existing models and help you to visualize them, because when you're doing them in bodybuilder, you're kind of taking a leap of faith and then you're processing them and then hope everything works out. Whereas in ProCalc, you kind of see everything in real time. You can see the segment definitions and make sure that you're doing everything correct before you even process. So from that side of it, it definitely helps to be doing things in ProCalc. And that kind of leads into the next question here, which was, does ProCalc replace bodybuilder? And I think in most cases, yes. There are some limitations to ProCalc, which we are aware of. Such things are being able to make or do kinetic calculations. That's definitely something that we have in mind. So it doesn't fully replace bodybuilder, but that is definitely the intent, that you can do pretty much all the same similar calculations as you can in bodybuilder, but you do have that one limitation. And again, it also extends because, if you can imagine, if you are a teacher in any capacity trying to teach someone bodybuilder versus trying to teach someone biomechanics through bodybuilder versus through ProCalc, it's pretty obvious or clear which option you would use. So I think it's not just potentially replacing bodybuilder, but it's adding a whole new option available to you that will just make everything easier for you and your students. Okay, so let's go back, because I've been going back and forth between the chat and the Q&A questions, trying to do them in order. Okay, so okay, so here's a question. Hello, can you add a segment in ProCalc to an existing model like plug-in gate, for example? So when you're adding segments, so I didn't anytime that I modified a segment in ProCalc, I was choosing an existing segment that already existed within my model. So I guess there's two questions here potentially. Is it that you want to do some VSK manipulation for the segments there, or you would actually like to add an additional segment? So in terms of like, you'd like to create like a multi-foot segment model. So you can go ahead and create as many segments as you want in ProCalc and do extra calculations to plug and gate. So you could add markers to plug and gate and then say, okay, well, I actually want a multi-segment foot model. You can go ahead and do that, no problem. As for adding a segment so that it is in your template, that won't be possible. You'll actually have to add the segment to your template first and then modify it within ProCalc. I hope I'm answering that question for you there. And then we've got a question. Is it possible to batch process multiple trials for a subset of calculations into Excel? Yeah, absolutely. So you can mark as many trials as you want, either within ProCalc, or you can do the batch processing that's available in Nexus and then just have a pipeline that's saved with the schemes that are relevant, and you can run through multiple different batch processing if you want to. Okay, I'm going to switch back over to the Q&A. Can we change any calculations or connect ProCalc to MATLAB Python? So what you can do is in MATLAB or Python is you can run pipelines. So if you specify your pipeline with ProCalc operations in there, you can certainly run it as part of a larger MATLAB script. So if you just have some simple calculations you want to do, because I mean, what you can do in ProCalc in one step may take you a few steps in MATLAB or Python. So I could definitely see the value there. So yeah, you could definitely run a pipeline in MATLAB or Python that's part of your script that will run some ProCalc operations, and then you can build off of that as necessary. And then we have, what additional resources are available for those who are new to using the system? So as I said, kind of there at the end, you do have obviously options for the YouTube, the docs.vicon.com, as well as please reach out to the support team at any time. We're always available. We're going to get back to you as soon as we can, and we're always happy to help with ProCalc questions, because I said it is pretty interesting, right? It extends your system and it goes beyond how do I just track these markers. It's like, what do I actually do with them? Okay, so then we have a question. Are all the parameters I compute stored in the MPX? So it's the XMP file I think that you're asking about there. Yes, so all of the parameters that you calculate in ProCalc are in the XMP file. So anything that you want, can be viewed there. So that's just within your session folder as well. Okay, sorry. There was a response to. Okay, sorry. There was a question earlier that was about the exporting Excel trajectories from ProCalc, but the commenter just clarified that they meant the angles. So again, I would do all of that exporting unless you were looking for specific times or those parameters. As I showed how you can export those, I would do all of the actual time series data exporting in Nexus as opposed to ProCalc. Okay, then we have, are the force plates there purely for visualization? No, so I guess I should clarify a little bit. You can get all of your force plate data within ProCalc. You just can't do any kinetics. It won't do any moments. It won't do any inverse dynamics or anything for you. But you can certainly look at the vectors, look at the values, and do calculations based off of that, especially if there's something to do with your events or something like that. You can do it that way, but you won't be able to do any kinetics in that way. Okay, so then we have a question here. Can you show a simulated real-time or kinfit example with a monitor and explain that use case further? Okay, sure. So let's go into Nexus really quickly. So this will be our first kind of interactive question that we're going to cover here. So the kinfit really just brings up the labeling skeleton. And as you can see here, since I've updated that using ProCalc, it should be with the orientations that I want for each segment. So what I might want to do is, and we'll kind of have to picture this in real time because I don't have anyone markered up right now. Okay, what I could do is I could go ahead and select, let's just expand on the joint. So I could look at the left thigh, left tibia, or yeah, you know, the knee angle essentially. I can split the screen here and pull up a graph, and this will actually show me the show me those angles, right? So what I want here is I'm going to want, let's say I was looking at knee flexion extension. I'm going to look at that y-axis, right? That green axis there. And let's say this is going to be different because this is going to be a ROM trial. So let's see if I do some squats in here. I don't. Okay, let's say I just wanted to know, you know, we had a subject that was there and we just wanted to know anytime they exceeded a certain knee angle, right? I could, again, please picture it as if this were live. I could go ahead and create a monitor here. We'll create a new monitor. We'll not save that. And to create a monitor, and this is kind of a different topic, but still pretty useful because you can do this in live, right? If you could picture maybe someone was squatting and you wanted to make sure that they were getting to the correct depth every single time, you could go ahead and do something like this so that you could get that, that feedback instantly, right? So I can go ahead and create a monitor for this graph view. And I really only want that Y. So let's go ahead and clear out a couple of these. Oops, I cleared that out by accident. So let's remove this. And I only want that Y-axis. So now I want to know anytime it goes above, let's pick a random value of 70. Right, so we can see this shaded area as that monitor, and whenever it enters, I just want a sound tone, let's say. Right, so now if I play this through, hopefully you guys can hear. I don't think my speakers. Okay, we'll do this differently. We'll put in an event instead because that'll be more clear to you. We'll put in a time bar event, and this is on my left side, so we'll make a left monitor. It doesn't really matter what the event type is, but now if I play through, anytime it crosses over that 70 going up, it will go ahead and put a bar here just to let me know that that's happening, right? So you can still get that kind of feedback in real time as well. So that is kind of the advantage of updating your VSK so that you can get pretty accurate feedback in real time for your trials. So thanks for that question. Let's go back here and make sure I didn't miss any. And let's see, where's the chat gone? Sorry. Okay. So I think I'm up to date on the, okay, so there was a question. So this is kind of a compounding question. How can we export this data from Excel? So let's go back into a previous trial. So I'm going to just minimize this for a second. Let's go to this 3D angle. And within here, I should have my model outputs. I have my elbow angle here, right? So the question is, how do I go ahead and export that angle? So in a new pipeline, let's just remove this one. Under the file export operations, I can go ahead and select export ASCII. So I just double click to bring that down. Nope, I did it twice. And what we can do is, this is under a model output. So I don't want any of my devices, so I'm going to select none. You just need to specify what exactly you want to export. So under model outputs, I'm going to just select all, and I don't need any trajectory data. So I'll go ahead and run that. And then this is going to be available to me within my session folder. So I click on this blue hyperlink here, and it was elbow angle FEO1, and you should see, let's just sort it by type, but I should have a CSV file for elbow FEO1, and you can see here now I've got my elbow angles. Obviously, we don't have Office installed on this computer, so you can see that even though I didn't, and I said that was an optional requirement, you can still get that data and you can still parse that data easily. So you do get your elbow angles for each frame in the XYZ. So hopefully I answered that one for you. All right. Okay. Schemes can become quite complicated, hard to follow what's going on. There's usually a logical order to how things are done, create vectors, and then create angle between. Is it possible to enable a way of sorting in this programming order? Unfortunately, not within ProCalc. What you can do is within your, and I'll show you, and hopefully you can see this, this folder here. What you can do is within your Eclipse database, if you look at one of these variable schemes, let's look at the 3D angle one, for example. And I'll just open this with Notepad. And hopefully, again, you guys can see this. I'll just hide some of these other things. This will actually show you everything that's in order. So if you're having a hard time kind of following what's going on, this will kind of show you the order in which you created each of those. So as I said, for that angle one, I looked at midpoints first, and then I defined vectors, and then I did segments, and then I calculated my Euler angle at the end. Alternatively, the feedback that you get from ProCalc is if I try to make a change to one of these, and these are all red right now because it doesn't see any of these marker labels because I'm looking at a lower body model right now, right? So if I went back, let's not save that. It was just asking me to save, or to make some save my changes, but I didn't have any. So if I go back here, if I wanted to make any changes to an existing calculation, it would tell me if I had any dependencies on that. So let's look at mid-elbow. Let's say I just wanted to change that to, I don't know, mid or something like that. Actually, I guess it did change. Let's see. Mid-elbow. Oh, it did change them for me. Okay, so that's not necessarily a good example. But it will show you what the dependencies on those calculations are. So I guess one thing that I could do is if I just cleared this out altogether. So if I just change that to that, it should bring up errors that down here at the bottom that I can't calculate those anymore. So it will let you know what some of the dependencies are for each of the calculations. Let's look at, can I use quaternions instead of Euler angles? Not in ProCalc, you can't, unfortunately. Yeah, unfortunately not. It's only going to be in Euler angles because that's typically how they are calculated or visualized biomechanically speaking. But there are scripts, especially within our Nexus MATLAB integration, where you can look at how to convert those Euler angles into quaternions. Can I choose where to save my schemes? Unfortunately not. It's going to be within that location that I specified before. So it's going to be here. It's going to be in your documents folder, Vicon, Eclipse, and then you're going to see your different events or variable schemes here. What I tend to do is, because obviously we support a lot of different customers, I create my own subfolders within there or somewhere else on my desktop and kind of separate them by use case or by customer or something like that. So that's right now the best way to kind of sort your data if that's kind of what you're getting at. Just to clarify, if I have a VST created in Nexus, can I label my subject with the existing VST markers, add a few more, and then create a new model in ProCalc? Yeah, absolutely. So the few more markers that you added would have to be obviously attached to a segment already. But yeah, if you, let's say, created a VST and then thought, oh, actually, this isn't going to give me the model that I wanted. This isn't going to give me the segment definition that I want. I want to add more markers and then redo it again. As long as you resave the C3D for that trial, you can definitely go ahead and create a new model in ProCalc. No problem at all. And then the last one, to clarify the limitations capabilities with kinetics, is it possible to use force in any self-calculated variables? For example, if I were to identify maximum vertical ground reaction force between foot strike and toe off using events and parameters. Thank you. Yeah, absolutely. So yeah, you can go through, let's go through an event right now. In fact, let's minimize this. And we'll just do, well, this may not be a good example because I don't think I have any. Let's see if I've actually got any force data in this one. Just wanted to actually show you that you could visualize. No, I don't even have force plates added in this one. But that doesn't stop me from, I guess, just showing you that you can get those values. So If I go ahead and add a new element, I can just choose a, I don't know, arithmetic, let's say. I should be able to choose a, what's it, number? It is under one, let's, I'm just trying to see where I can, oh, because this one doesn't have force plates, that's why they're not there. Let's at least open a trial that has force plates in there. Sorry about this. Let's see, So this one should, yeah, okay, it at least should have force plates in there. Do the same thing, we should have that force. Okay, so we'll add that force one back in, force. And you can see here that I've got my different channels here, so I could just look at the FZ, for example. I won't actually have anything to display, but it'll just be, I guess, noise in this case. I don't really have any vectors there, but you can definitely use those in your event thresholds as well. So they're just going to be accessible as a number. So again, you're not going to be able to do any inverse dynamics or anything like that, but you can definitely obtain the force values there. Okay, so just that. Does ProCalc help to solve the gimbal lock problem? Unfortunately not. It's not going to be, the only thing that you can do obviously is change your rotation orders. So if you kind of have an idea of where you might have a problem, you could go ahead and change your rotation order in that way. This is a good question, and this is probably a question that I have. What and why Conga, the default scheme that's installed? I'm gonna have to escalate that question. I don't know. Yeah, I don't have a good answer for you for that one, unfortunately. Okay, and last question, I think, is it possible to calculate a segment between A and B using the average position of two markers as point B? So, is it possible to calculate a segment between A and B? So I'm not sure necessarily what you mean by calculate a segment between A and B. Are you saying that? Yeah, I'm not too sure. You can certainly get the average position of two markers. Oh, okay. Sorry, okay, a vector going from A to B. Okay, so if you only have 2 points, unfortunately, you won't be able to really define a segment because we won't know the orientation of that vector. So you're going to need at least 3 points. But definitely, they can be going from A to B, and B can be midpoint. In my example here with the 3D angle, as an example, if I load that up. Oh, okay. Sorry, it just wanted me to. No. Okay, so let's look at this example here. In my 3D angle example, that's exactly what I did. I mean, I have essentially midpoints for the elbow, shoulder, and wrist, and then I've used vectors going from the shoulder to elbow, and then the elbow to wrist as part of my definition for each of those segments. So that's how you could use midpoints to calculate segments. But with just 2 markers, unfortunately, you won't be able to get a segment definition. And I think let's just check the chat really quickly to make sure there's not. Oh, there's potentially one more. Oh, thank you. Well, you guys are welcome. Again, I really hope you enjoyed it, and we did go over time just a little bit. But if you do want to review at any time, please go ahead and watch the video in the link. And again, I will upload the trials and the schemes as well as the presentation so that you can view that later.
Awesome. Yes. So like you said, there'll be a link to all of this. You'll get an email tomorrow from Zoom with the recording link, but you can also go back through your registration to find it as soon as it processes after this. And just email us at support@Vicon with other questions. I see I missed the previous webinar. Can I get access? Yes, definitely. So if you go to any of our social media channels and use that registration link for the Vantage Plus webinar, it'll just take you to a page. Instead of registration for the live session, it'll take you to a page that says this webinar is over, register for the recording. So you can do that for last week's or the future. And then, like I said, tomorrow you'll get the link directly to your email from Zoom as well.
I will say that I did get one last question in there, so I'll just try to fit that in before we end here, because you know, obviously we want to take it if you're still here. So it says, can ProCalc be used to calculate segment angles in relation to the laboratory coordinate system? Absolutely, and I can show you that quickly here. So if we just add a new element, I'll just call this example, and then we'll choose an angle, and we'll just choose any rotation, really doesn't matter. But one segment could be the upper arm, and then the other segment, by default, we already have the lab coordinate system. So you can kind of see that gets calculated. So it's actually a fairly easy thing to do. And you know, maybe that's something you want to do for like a tibia inclination angle or something like that, or a foot progression angle, something like that. So those are very easy things that you can do with the laboratory coordinate system. But it's in there by default. I didn't have to create it or anything like that.
Awesome. And I just posted the registration link for the Vantage Plus webinar in the chat. So if you missed that one and want to see the recording, you can go through that link. Do we have any other questions? All right. Well, this has been great, guys. Thank you for joining us and all those awesome questions. And you can just send any others to us and we'll post them on social media if we find those to be helpful to the webinar community at large.
And I think, yeah, if you do add questions probably to the YouTube as well, I'll go on there and answer those questions after as well.
Definitely. Sweet. All right.
Thanks,
well,
guys.
thank you guys for joining us. We'll see you next week.